Right. So once again, folks, let's see if we can resolve this problem which involve graphs of motion. I hope you guys will find it interesting. Let's start. There is a graph of motion, and if I try and inspect, it looks like it's displacement time where gradient gives us velocity, and where displacement is not changing, it tells us the velocity is 0. So let's see what we're told. Displacement of a particle t seconds after leaving a fixed point 0 is s meters. The diagram shows the displacement time graph which models the motion of the particle. The graph consists of 4 straight line segments. The particle travels 50 meters in the first 10 seconds, then travels at 2 meters per second for a period of 10 seconds. The particle then comes to rest for a period of 20 seconds before returning to its starting point. So we can see that there it's where it was furthest away from its starting point. Find the velocity of the particle during the last 20 seconds of the motion. So our interest is the velocity of the particle during the last 20 seconds. So velocity is going to be equal to the slope of this curve. And how do we find slope of the curve? Let's check information we are given. I'm sure it can assist us to find the displacement at this point. What we know is from the 10 seconds where it was accelerating, we are told that it travels at 2 meters per second for 10 seconds. Then from this, we can tell its displacement because it's going to be distance given by speed multiplied by time. So our speed there is 2 and our time is 10. So it means from this period up to there, it traveled 20 meters, implying this is going to be 50 plus 20. That's actually 70 meters. So what we know is here it's 70 meters and finally it's 0. And the time frame here is 20. So if we want the velocity during the last interval there, it's going to be the slope of the curve, which we find as let's say v equal to final speed, which is 0 minus initially it was 70 over change in time, which was 20. And when we do our simplifications there, it looks like this will take us to minus 3.5 meters per second. Right, let's check what's required. Sketch a velocity time graph for the motion of the particle from 0 to 0 to 60 seconds. So I'm trying to sketch the velocity time graph. So here I have velocity, there I have time. This graph is going to be made up of straight line sections. Let's try and check within the first 10 seconds, what was happening? So we have 0, 10, 20, 40, 60. So let me try and sketch those points. So it will be 0 up to 60. So let me come down to my plane and say this is 0, 10, 20, 30, 40, 50, 60. Let's see, you can have 2, 4, 6. It looks like there was a negative velocity there, so we can expect a bit of -2, -4, going down like that. Then we can try and check what was its velocity during the first 10 seconds. It will be just a graph of this. So it's changing displacement over change in time. So for this section here, is going to be 50 divided by 10, which is 5 meters per second. So if I come to my graph there, I know that within the first 10 seconds, it was at 5. 5 is here. So this was the scenario. So it's an instantaneous change. Let's check what will happen after those first 10 seconds. The next 10, we're given the velocity as 2 meters per second. So that one is given. We can come back to our graph and say, all right, in the next 10 seconds, the velocity will be here. Then an instant change. We come and check what's happening. Next is 20 seconds. And within those 20 seconds, the object is stationary. So when it's stationary, it implies that its velocity is 0. So I'll come and say the next 20 seconds it was there. Then let's check what comes after that. Last 20 seconds. So last 20 seconds, the velocity, we calculated it, it was at negative 3.5, which we find here. So we drop and say at that point, that's the scenario we have. So that's the velocity time graph of that object's displacement over time sketch. Right, let's have a look at the last problem there, where we are given a velocity time graph, and we know the gradient here is going to be equal to acceleration. So let's check what we are told. The velocity of a particle moving in a straight line at a time t seconds after leaving a point or is v meters per second. So the diagram shows the velocity time graph, which models motion of the particle from time t equal to 0 up to time t equal to t. The graph consists of four straight line segments. Now the particle accelerates from rest to the speed of v meters per second over a period of 4 seconds. And then decelerates at, so we are given the magnitude of deceleration there, where acceleration will be minus 5 over 3 meters per second squared to instantaneous rest equal to 6, where this negative could travel meters per second before coming to rest. So we are told that the time will be t seconds there. The value of v. But the information we have is there's a time of 6 seconds there, and we know that somewhere it reaches a velocity v of 0, and the acceleration is minus 5 over 3. So in order for us to find this v here, v is going to be our initial velocity, so which is not known for this section. Now, if I look at the variables that I have got a feeling v equal to u plus at can assist me, where v, the final velocity, is 0 there. Initially, is what we are looking for, which is the u there. Let me probably put the correct variable to say we are interested in u. Oh, well, u, we are saying is corresponding to the v that we have. Hence, I put v there, plus our acceleration is 5 over 3. But remember, it's negative because it's deceleration over the time, which was 6 seconds. And when I simplify there, it looks like my v actually is v is going to be plus minus 10. So v in actual fact is 10 meters per second. So this is 10. So I found my v. So v there is actually 10. Given that the total distance traveled by the particle from t0 to, or total distance traveled, so is 68 meters, find the value of t. What are we saying? Now that we have found the value of v, area under the curve, this area, right, and this one, we are told the total is 68. But remember, this is a triangle whose area we can easily find. It's half base times height. So for this section, the base is 10, the height is 10. So if I come down here, I can choose to say for the first section, area of 1 is half of 10, 10 times 10, which will give me 50 meters. But remember, the total distance is given as 68. So if I remove the 50, I'll remain with the distance traveled below the graph, which is going to be, it looks like here it's going to be 18 meters. So now, if I come back to the graph and check, what are we saying? We are saying this section is made up of 18 meters. But remember, this part, which is our base, is t minus 10, and this is 3. So half t minus 10. I'll come down and say for that section, area is half t minus 10 multiplied by 3. This will be equal to 18. And when I do my mathematics there, it looks like t minus 10 is going to be equal to, when I divide both sides by 3, gives me 6, but when I multiply 6 by, so it gives me 12. Therefore, my t in essence is equal to 22 seconds. I think that's all we have on those two questions centered around graphs of motion. Thank you.